Hello students, welcome to Sarasa classes. Now continuing with the disconnection approach in which we were discussing CX disconnection 1, 1 type. So we are going to use the same principles in disconnecting alpha amino acids. So what is your alpha amino acid? We have a R, we have a H, we have a carboxylic acid group and we have a NH2 attached to a carbon. Now if you do the functional group interconversion, so in that we will convert the carboxylic group to cyano and NH3 remains as NH2. Then we will do the 1, 1 disconnection. Okay, that would generate what? RH plus the synthon, and we have Cn minus and NH2 minus, for which the reagents obviously will be, if we do addition of proton for both the synthons, we get HCN and NH3 correspondingly. And for this one, for any synthon that is having plus plus on the carbon, I have said before, always add O2 minus. So that will give you the corresponding aldehyde. Now, if we were to do the analysis, that is the retrosynthetic analysis of a amino acid, then let's take the example of aniline, which is, say, this. Let's do the FGI, and it converts the carboxylic group to cyano, followed up by the disconnection at the 1, 1 position, that is 1, 1 DIX, and then the synthons we get are as follows, for which we will add O2 minus, so we are getting CH3, C double bond OH, and we have Cn and NH2. So if we add the protons, we get HCN and NH3. Now, while synthesizing this molecule, what we will consider? We will consider the Strecker synthesis. So over here we have a acetaldehyde which has been treated with ammonium carbonate in presence of HCN. That will give us CH3H, CnNH2, and that when treated with NaOH in aqueous medium undergoes hydrolysis of cyano group in presence of alkaline medium, or we can do this in the acidic medium. Both can be used, and it will lead us to give the desired amino acid, which is the aniline, our target molecule. The following can be also extended for the retrosynthetic analysis of another molecule, which is obviously, let's consider this one. And it is something like that. We have NH2 and C double bond OH. What have we learned? We have to do FGI and convert the carboxylic group to cyano. So that is what we do. So this becomes cyano, this remains as NH2, and those are my hydroxyl groups. Alright, now out here if we disconnect using 1,1 DIX, then the synthons that we get are as follows. We have NH2 minus and CNN minus. So from here we will write the synthons will lead to the formation of, say if we add O2 minus, then what do we get? This type of a ketone, and obviously from NH2 we will get NH3, and from Cn minus we will get HCN. And now if we were to think of the synthesis of this molecule, that is this target material, let us call this over here as 3. Okay, so we will say this is being treated with ammonium carbonate in presence of HCN, and that will give us this particular molecule, which on further hydrolysis, say in acidic medium, will give us the target material 3, which is this one. Okay, next we will disconnect. So this is our D. Let's say we are considering the disconnection of alpha haloethers. So how to find out the starting materials of alpha haloethers? For that, it is very similar to that of an disconnection of a acetal or a ketal. So we have a basically R connected to OR prime, and over here we have a Cl. And suppose we are doing 1,1 DIX. So we disconnect over here. Then that will lead to the formation of synthons like this. So this is OR prime minus, and this is Cl minus. So the synthons will lead to the reagents. Here when I have dipositive carbon, I will always add O2 minus, so that will give me the ketone like this, and we will add obviously H plus to neutralize the minus charge. Okay, so this gives me ROH prime, and this is going to be your HCl. So having learned the disconnection approach for alpha haloethers, let us apply this on a molecule. So we are doing the analysis of this alpha haloether. So let us consider MEO CH2 CH2O CH2Cl. All right. So we will be considering the disconnection of this unit out here. Okay. So this carbon over here is having two hydrogens like that. And if you disconnect over here, then what are the synthons that we generate? Obviously it is Cl minus, and we have a OMe CH2 CH2 O minus. All right. Plus we have the other synthon, which is obviously CH2 plus plus. Now this we will add O2 minus, that becomes formaldehyde. From here, if we do H plus, becomes HCl. Besides that, if we do H plus over here, it becomes MEOCH2CH2OH. Now, if we consider the synthesis of this, say, target material 4 or target molecule 4, then what we need to do, we need to have the formaldehyde, or let's write it like this to have better clarity, in presence of HCl and with this alcohol, and that will give us our target molecule 4. As simple as that. Thanks for listening. Keep visiting Sourcer classes for the next part of disconnection approach, in which we will take up 1,2 difunctionalized compounds. Thanks for listening. Have a great day.